This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 2, Lesson 5, Internal Gains, Part 2, Appliances and Kitchen Equipment. This is the last major internal gain. The handbook prints a generic equation for hooded appliances and 4 pages of tabulated kitchen rates. One idea ties all of it together. A hood pulls the convective and latent plume up the duct, so only the radiant heat reaches the room. We'll ground that, then work a hooded versus unhooded gain. Concept 1. The hood decides everything. An appliance sheds heat 3 ways: radiant along straight lines, convective in a hot plume, and latent as moisture. With no hood, all 3 land in the room, so the gain is the total from the table. Add an exhaust hood, and it captures the rising plume and its moisture and throws them outside. Only the radiant heat still reaches the space. So a hooded appliance's gain is just the radiant column. Concept 2. The generic equation. For a hooded electric, steam, or gas appliance, the sensible gain is the rated input times a usage factor times a radiation factor. Input is the nameplate rating. The usage factor drops it to the real idle rate. The radiation factor is the fraction radiated into the room. There's also an FL form, input times FL, but that's an alternative to usage times radiation, not a third multiplier. Because it's a hooded equation, it returns the radiant gain. Concept 3. The nameplate is not the gain. Rated input is a peak figure, and the tables report idle, ready-to-cook rates, not full cooking rates. The usage factor turns rated input into the idle standby heat. The radiation factor then keeps only the radiant slice. Each factor is a real physical step, from nameplate down to what the space actually feels. Never plug the nameplate straight in. Concept 4. The 4 tables. The kitchen gains span 4 pages, and the columns depend on the hood. Unhooded lists radiant, convective, latent, and a total. The hooded tables, electric, gas, and solid fuel, list radiant only, because the plume is gone. Every row also gives the rated energy, the idle rate, and its own usage and radiation factors. Match the row to the fuel and to whether there's a hood. Setup. 1 appliance, 2 questions. A single burner high-speed hot plate. The unhooded table hands us the whole row. Rated input 3,800, a usage factor of 0.79, a radiation factor of 0.30, a total of 3,000, and a radiant slice of 900. Latent is 0. It's a dry appliance. Now, how much does the space feel with a hood and without one? Solve. Unhooded, everything reaches the room, so read the total column, 3,000. Hooded, only radiant survives, so apply the generic equation, input times usage times radiation. 3,800 times 0.79 times 0.30 is 900, which matches the table's radiant column exactly. The hood cut the load from 3,000 to 900, capturing the 2,100 convective plume. And that same equation reproduces the hooded table straight. A hot top range gives 11,800, its printed radiant value. Traps. 5 ways this bites. 1. Hooded versus unhooded is the whole game. Unhooded read the total, hooded read radiant only, and the generic equation is a hooded equation. 2. That equation gives no latent. For a moist unhooded appliance, add the latent column. 3. The nameplate is not the gain. Apply both factors. 4. FL is an alternative to usage times radiation, not a third multiplier. 5. Every rate is idle, not peak cooking. Quick recall. The hood picks the column, unhooded read the total, hooded read the radiant. The generic equation, input times usage times radiation, gives that hooded radiant gain, with an FL form as an alternative. Latent isn't in the equation. Read it off the unhooded table. The tables run 4 pages by fuel and hood. Golden rule, ask whether it's hooded first. It sets the column and whether latent even counts. Next up, Lesson 6, Infiltration Loads. That wraps the internal gains. Now we step outside, to air leaking in through the envelope. The handbook prints one residential method, the effective leakage area model, then turns that airflow into a load with the same standard air factors from Lesson 1. Everything's at peprepengine.com. cheat sheet, worked solution, and a quiz attached here.
The full study guide with every equation and common exam trap is free at peprepengine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.